So our next step is we have spent a lot of time talking about different types of relationships and the rules that those relationships have in the equation. So let's talk about the different equations that we've had so far. This is a monologue.
I got you. I thought you were like.
So, the four types of relationships we've talked about. We have linear. We have inverse. We have exponential. If I spell something wrong, I'm sorry, but I don't care. And quadratic. All right, so, thank you. All right, so these are the four types of relationships we've studied. Oh man, you got me Starbucks?
No.
Oh, come on,
You got
right?
your donuts though.
You got me donuts?
Yeah.
Okay.
Yes.
Okay, after this video, yeah, we'll have a donut.
Got you.
All right, so, okay, so in linear relationships, the most basic equation that we've talked about is called slope. Oh, sorry about that. So slope intercept form. And the slope intercept form is called slope intercept form because it has a slope and the y-intercept in the equation. That is your classic y equals mx plus b, where m is equal to slope and b is equal to y-intercept. Back in September, we also talked about something that is called standard form. Now, standard form is going to be very important when we start talking about solving systems of equations. This is absolutely going to come back and be something we see a lot of. So, standard form is defined by ax plus by is equal to c. In other words, we have x and y on the same side of the equal sign, and we have the constant by itself. The plain old number will be by itself. A couple of extra rules. A, B, and C are all numbers. They are, A and B are obviously coefficients. C is a constant. And in standard form, there are no fractions. That includes decimals. And A is positive. B and C can be negative, that's fine. A is positive. Let me finish linear and then I'll take a question, okay? All right, the last form of a linear equation that we have talked about is called point slope form, where you have a point, we're going to call that point x1 comma y1, and you have a slope, and slope is m. And point slope form is written y minus y1 is equal to m times x minus x1. Now there are some other forms like intercept form, which has both the x and y intercept, but we're not going to worry about that now. All right, Sabina, is there a question? Now that will not be on the test. However, to convert from one form to the other, all you have to do is use train tracks. So you would want to move this over here, and then make sure that x is positive and there are no fractions. Yes?
Wait, so for the point slope form, you would multiply y minus y1 to x minus x1?
No. So we have y minus y1, and that is equal to the slope, m, times the quantity, x minus x1.
Okay.
So the only thing that gets multiplied out there is the slope. Inverse equations are pretty straightforward. They simply are x times y equals a constant, or you have y is equal to that same constant divided by x. So if you have x in a denominator, it is going to be inverse. Simple. Exponential relationships can get a little bit tricky in writing equations, so I'll do my best on this one. But in terms of identifying, just for the record, I think Theo just did well in his snowboard or video game.
No, it's Spanish. It's Spanish homework. It's Spanish homework.
Or it's the Spanish homework. Alright.
It is.
I've been watching them do the snowboarding game for the last 10 minutes.
Snowboarding?
It was skiing actually.
Snow rider.
Ever snowboarding is better. Alright,
No, it's
so
not. Snowboarding.
Snow rider is not hard to find.
So
My
in
fault.
exponential, we have y is equal to a times b to the power of x, where a is the y-intercept and b is the growth factor.
Wait, I thought that exponential equations didn't have a y intercept.
No, exponential does, inverse does not.
As
So-
guys, never touch a zero.
Hold on a second. I just want to check something. All right. So the one tricky thing is the equation for exponential relationships are the same whether it is decay or growth. So if we have a b value that is greater than 1, then you will have growth or decay.
Growth.
Growth. If you have b less than 1, we will have decay. The key in identifying exponential equations is that you have a variable, a letter, as the exponent. All right. Finally, in quadratics, we have expanded form. Which is ax squared plus bx plus c, and that is going to be equal to 0. Factored form is going to be x minus h times x minus k, and h and k. Well, h and k are the intercepts. That is the x-intercepts. Now, this piece only applies as long as you have a coefficient of 1 on both of these x's. If you don't have a coefficient of 1 on both these x's, to solve it, you have to break it apart, set it equal to 0, and you have 2 separate train track problems. Yes, Abby?
Wait, what is that for? Like, why do you need to, like, set it up, the equation?
If you're being asked to find the x-intercepts.
Thank you.
How is that? Brendan looks at us like.
All right. Finally, there is another form of a quadratic that we have not really spent any time talking about, but it is actually pretty important. And it is y, that's a y, is equal to a times x minus x1 plus y1. And just heads up, that is going to be called vertex form.
Will that be on the test? Oh, so.
This will, well, it will be, in terms of the matching, it will be match a quadratic expression that is not a form that we have studied before. Which is fair, because have we studied this?
No, not really.
No.
Okay.
But it's called vertex form because the vertex is right there.
What-
Yes.
So
Oh, shoot, there's a squared here.
x,
My bad.
so the x's are the x-intercepts, right? Or no?
So the factored form gives you the x-intercepts and the,
No, for that form. The
For-
x's are the x-intercepts?
no, in which form? The third or?
Yeah, the last one that you just.
No, this is the vertex. Which is why it's called vertex form. Alright, so those are the types of equations that you may have to match.